Section 2.7 is going to be an introduction to graphing rational functions. Now, last year you graphed some rational functions, and they were simple ones with horizontal and vertical asymptotes, and they're still going to go on here, but when we have more than one vertical asymptote, or if we have a hole in the graph, things are a little bit different. So the steps to do these graphs are going to be a little bit more in depth than the steps to graph the previous ones from Algebra 2 with trig. So the first thing we want to do is we want to factor out the numerator and denominator completely if possible. Then find the x-intercepts by setting the numerator equal to 0 and solve. And sometimes there may not be an x-intercept, or there could be more than one x-intercept. So we set it equal to 0 and solve. Then we find the y-intercept by plugging in 0 for x if we can. So if we may have situations where if we substitute 0 in for x, we will get a 0 in the denominator, but we at least try to find that y-intercept. Find holes in the graphs if they exist. Remember, that is when you can cancel a factor for the numerator and denominator. Set the denominator equal to 0 to find any asymptotes, vertical asymptotes. Find horizontal or oblique asymptotes. So oblique asymptotes, those are new, and we're going to focus on those more tomorrow, but they're also called slanted asymptotes. And then we're going to use the vertical behavior. We could find one point between all x-intercepts in the VAs, but using the vertical behavior is a little bit easier because we're not finding as many points. So our first example here, we're going to graph f of x equals 3 over x minus 5. So the first step, we said we're going to find we're going to factor the numerator and denominator. It's already factored. So then our x-intercepts, we set the numerator to 0. So 3 equals 0. Well, that's not true, so that means there is no x-intercepts. Then our y-intercept is when we plug in 0. So f of 0 is 3 over 0 minus 5, which is going to be negative, we'll write it as an ordered pair, 0 comma negative 3 over 5 is our y-intercept. Then our VA, vertical asymptote, we set the denominator equal to 0. It's always the denominator once you've crossed off any common factors, because you can't have a vertical asymptote and a hole at the same time. So you factor, find any holes in your graph, and then set the remaining denominator equal to 0. And now our horizontal asymptote, the degree in the denominator is 1. There is no x in the numerator, so the degree of the numerator is 0. So the degree in the denominator is larger than the degree of the numerator, so y equals 0 is our horizontal asymptote. So let's go over here and plot our information. Horizontal asymptote, y equals 0. Vertical asymptote was x equals 5, so 1, 2, 3, 4, 5. Then our y-intercept was 0 comma negative 3/5, so right around there. Now we have to figure out which direction this goes in, because one of the other new things for PreCalc, and our horizontal asymptote, we can now cross horizontal asymptotes. We can now cross horizontal asymptotes. So last year we said no, we couldn't cross them, but now we can. So it is important for us to calculate that end behavior and that vertical behavior. So for our vertical behavior, we're going to calculate points around 5. So we're going to do like positive 5.1 and positive 4.9. And again, like yesterday, we're just trying to determine, is it going to be positive or negative? So our vertical behavior, so f of 4.9 equals 3 over 4.9 minus 5. So yes, you can use a calculator if you want, but I know that the numerator is positive. The denominator is going to be negative because 4.9 minus 5 is going to give us a negative number. So positive divided by negative is negative, so left is down. And then we'll do f of 5.1 equals 3 over 5.1 minus 5. Well, the numerator is positive. The denominator will be positive as well. So it's going to be positive, so right side up. And again, look at our asymptote. If we get infinitely close, the y values are either going to be a negative value or a positive value, because we know our graph will either go like this or like that and go down. So knowing that our value is positive or negative will tell us which way it goes. All right, then end behavior. So this is when we substitute a value like negative 1,000 and positive 1,000 to see if we are above or below the asymptote. So f of negative 1,000 equals 3 over negative 1,000 minus 5. So again, in the calculator, we just want to see if this is above or below our horizontal asymptote. So 3 divided by parentheses negative 1,000 minus 5, we get negative 0.003, which is less than our asymptote, so we're going to be below. And then f of 1,000, positive 1,000 minus 5, that's going to be positive 0.003, which is greater than 0, so above. So now we're going to put this together. We know that the left side is going to be below the asymptote because negative 1,000, that y value, or that x value is over here. So we know that it's going to come this way, and then we know that the vertical behavior coming from this side is negative, so it goes down like that. That we know the vertical behavior from the other side is positive, so it's going to come up, down from here, and then we are above the asymptote. Now you might be saying, can I just use a general rule to know how this will look? And the general rules from last year apply in about 95, 96% of the situations, but you'll need to be able to figure out 100% of the time what these graphs look like. All right, so example number 2, we are going to factor this. So when we factor the numerator, we get x plus 3 times x plus 2. And in the denominator, we get x plus 3 times x plus 1. So we see that we have these two x plus 3's that are in common. They would cancel, and we'd be left with x plus 2 over x plus 1. So we do have a hole at x equals 3. Or sorry, x equals negative 3. Because that's what makes this factor 0. So we will want to write that down in a minute. So now to find out our x-intercept, x-intercept is we're going to set the numerator equal to 0, and it's always the new function that we're working with now, the reduced one. So x plus 2 equals 0. X equals -2, so we have -2 comma 0 as our x-intercept. Our y-intercept, for our y-intercept, we are going to substitute y in, or 0 in for x. So 0 plus 2 over 0 plus 1 equals 2 over 1. So that means our y-intercept is 0 comma 2. Our vertical asymptote, VA, is going to be when the denominator equals 0, the new denominator, so x equals -1. And then the horizontal asymptote is going to be the ratio of our leading coefficients because our degree is the same. Our degree is 1 in the top and 1 in the bottom. So our horizontal asymptote is, like I said, the ratio of the leading coefficients 1 over 1, the number in front of these x's, which is 1. And then, like I was saying, we have a hole at x equals -3 because that's what makes that part equal 0. So let's go over and plot this information. We can't really plot the hole yet until we know what the graph looks like. So our vertical asymptote is at -1. Our horizontal asymptote is at +1. And now we have to do the behaviors. Our vertical behavior, okay, so our asymptote is x equals -1, so we want to be on either side of it. So we're going to do f of -1.1, and then again we're going to substitute that into our highlighted function up there. So -1.1 plus 2 over -1.1 plus 1. Well, again, we have a positive in the numerator because -1.1 plus 2 is positive. In the denominator, we're going to have a negative. So positive over negative is negative, so the left side will go down. And then we need to go from the other direction. So f of -0.9 equals -0.9 plus 2 over -0.9 plus 1. Well, we're going to have a positive over positive, so that will be positive, so the right side is up. Now the end behavior. With our end behavior here, and behavior, again, we're going to substitute -1,000, and that's again going to go into the simplified function, -1,000 plus 2 over -1,000 plus 1, and we get 0.999, which is less than 1, our asymptote, so it's going to be below. And then f of 1,000 is going to be 1,000 plus 2 over 1,000 plus 1, which is equal to 1.001, which is greater than our asymptote, so above. All right, so now let's plot our x-intercept and y-intercept. Our y-intercept was 0, 2. Our x-intercept was -2, 0. And our behavior, the left side is going to be below the asymptote. So it's going to come this way. But remember, we have a hole at -3, and that is how we would draw the hole. Just like a dot, but not filled in. Then the left side of our asymptote goes down. So it's going to go down like this. The right side up, and then our right end behavior is above the asymptote. So that's how our graph would look like with the whole divided out. And again, like you might be able to look at this and say, well, don't I just know that the end behavior is going to be one side's above, one side's below? Don't I just know that the vertical behavior will be like that because one's got to go up, one's got to go down? Now that's not always the case, and a couple more examples later you'll see that. All right, so example 3, let's go ahead and factor the numerator and denominator. Numerator is already factored. The denominator factors to x minus 3 times x plus 1. So unfortunately, we can't cancel anything from the numerator and denominator. So then let's go through our steps. Our x-intercept. X-intercept, again, we're going to set the numerator equal to 0. So x minus 2 equals 0. X is going to equal to positive 2. So 2 comma 0 is our x-intercept. Then our y-intercept. For our y-intercept, we're going to substitute 0 in for x. So 0 minus 2 over 0 minus 3 times 0 plus 1. You could substitute it into the original one, the unfactored one. We always use the factored one for everything else. I just decided to use it for this one as well. So we get negative 2 over negative 3. So 0 comma positive 2/3 is our y-intercept. Horizontal asymptotes. Sorry, vertical. We'll do that first. Vertical asymptotes. Set the denominators equal to 0, so our two zeros will be x equals 3 and x equals negative 1. So having two vertical asymptotes, means we're going to have to do the vertical behavior for both of them. And then the horizontal asymptote, we can use the original one. The degree in the denominator is bigger than the degree in the numerator, so y equals 0. So let's do y equals 0. We have a vertical asymptote at negative 1 and at positive 3. Our x-intercept is 2 comma 0. And our y-intercept is 0 comma 2/3, so about there. So yeah, we don't know what's going to go on in between those asymptotes. Is our function going to do this? Is it going to do this? We don't know. Or is it going to do this? That's why we need to do the vertical behavior of both asymptotes to know what's going to happen. So vertical behavior, so f of negative 1.1, so we have negative 1.1 minus 2 over negative 1.1 minus 3 times negative 1.1 plus 1. And when you have multiple factors like this, then you might really need to look and use your calculator to see if you're going to have a positive or negative value. So in the numerator, we have negative 1.1 minus 2. And in the denominator, negative 1.1 minus 3 times negative 1.1, times negative 1.1 plus 1, positive. So we have a negative in the numerator, positive in the denominator, so it's going to be negative, so left side down. Now we're going to do negative 0.9. So we have negative 0.9 minus 2 over negative 0.9 minus 3 times negative 0.9 plus 1. So we're going to have a negative in the numerator, and the denominator is also going to be negative, because again, if we go and do parentheses negative 0.9 minus 3 times parentheses negative 0.9 plus 1. So we have a negative in the numerator, negative in the denominator, so it's going to be a positive, so right side up. So then we have to do for f of 2.9, so 2.9 minus 2 over 2.9 minus 3 times 2.9 plus 1. Well, that's going to give us a positive in the numerator, but the denominator will still be negative. So it's going to be negative, so left side down. And then f of 3.1 is going to be 3.1 minus 2 over 3.1 minus 3, 3.1 plus 1. And that's going to be positive. And one way to think about it is this factor is positive. 3.1 minus 2 is going to give you a positive number. This factor is positive. 3.1 minus 3 is a positive number. This factor is also positive. So everything is positive. So positive right hand up. So for these n behaviors, f of negative 1,000 equals negative 1,000 minus 2 over negative 1,000 minus 3 is negative 1,000 plus 1. And in the calculator, that is going to give us negative 0.001, which is less than 0, the asymptote. So it's going to be below. Then f of positive 1,000 is going to be 1,000 minus 2 over 1,000 minus 3 times 1,000 plus 1. And that gives us positive 0.001, which is greater than 0, so above. Oops. Above. So now let's go back at our graph. We said that the left side is going to be below the asymptote, and that our vertical behavior here is down. Then our vertical behavior on the other side of the asymptote, the right side, it's up. So it comes down and it has to touch these points. And then the vertical behavior for the asymptote at 3, the left side's down and the right side is up. So it's got to come down this way. And then finally, the right side again was up, and the positive end behavior was above. So you may notice something right here. We crossed our horizontal asymptote. Our horizontal asymptote was at y equals 0, but our y-intercept was 2, 0. So we crossed the asymptote right here. And that is why you have to do the vertical behavior and the end behavior as well. All right, last one. We have negative x plus x squared over x squared minus 4. I don't like how that's written, so we know that we can rearrange this x squared minus x over x squared minus 4. And we can factor the numerator, so x times x minus 1. And we can factor the denominator to x minus 2 times x plus 2. And we can't cancel anything, so we're going to have to deal with this bit of a mess. X-intercepts, we're going to have 2 x-intercepts because we have x times x minus 1 equals 0. So our 2 intercepts, we're going to have one at 0, 0, and we're going to have one at positive 1 comma 0. All right, so for the y-intercept now, we can substitute 0 in, and you can substitute 0 into any of these functions, any of the three that we have above. I'm going to choose the middle one. So 0 squared minus 0 over 0 squared minus 4. Well, we get a 0 in the numerator, so that's just going to be 0. So f of 0 is equal to 0. 0, 0 is a y-intercept. Well, notice that your x and y-intercept are exactly the same. That can happen, and that's okay if it does. All right, now our vertical asymptotes. Vertical asymptote is x equals 2 and x equals negative 2. Horizontal asymptote. The degree in the top and the degree in the bottom are the same, so it's going to be the ratio of these leading coefficients, so y equals 1 over 1, or 1. All right, so we have our horizontal asymptote at y equals 1. We have vertical asymptotes at x equals negative 2 and x equals positive 2. And we have two x-intercepts at 0, 0 and at 1, 0. And you may say, well, I know then the graph will have to go, this way. But we don't know that. We know in that previous problem we were able to cross the horizontal asymptote. So how do we know that this doesn't go like that? We don't, and that's why we have to do this end behavior stuff and vertical behavior. So vertical behavior for the negative 2 asymptote. So vertical behavior, so we're going to do f of negative 2.1. So that's negative 2.1 times negative 2.1 minus 1 over negative 2.1 plus 2 times negative 2.1 minus 2. And if we type that in your calculator, you're going to get a positive number. So positive means left side up. And then we're going to do f of negative 1.9. So we have negative 1.9 times negative 1.9 minus 1 over negative 1.9 plus 2 over negative 1.9 minus 2. And we type that in your calculator and you get a positive number, sorry, a negative number, so that means negative, the right side's down. So now we have to work with the positive 2 asymptote, so f of positive 1.9. Okay, so we're going to do 1.9 times 1.9 minus 1 over 1.9 plus 2 times 1.9 minus 2 equals, that is going to, if we type that in the calculator, we get a negative value. And again, it doesn't matter what that value is it just positive or negative? So, oops, negative. So the left side of that asymptote is down. And then f of 2.1. All right, we got 2.1 times 2.1 minus 1 over 2.1 plus 2 times 2.1 minus 2. And we type that in the calculator, we get a positive number. So the right side is up. All right, now we have to do the end behavior. But we know that the left side of the first asymptote is up. So we know it's got to go this way. But we don't know, do we cross at the horizontal asymptote? So we don't know that part yet. We know that the right side, never mind. So then the end behavior. End behavior. We're going to do f of negative 1,000. So it's negative 1,000 times negative 1,000 minus 1 over negative 1,000 plus 2 times negative 1,000 minus 2, and we get 1.001, 001, which is greater than 1, so that's above, and then f of 1,000 is 1,000 times 1,000 minus 1 over 1,000 plus 2 times 1,000 minus 2, which is 0.99, which is less than 1, so below. So we should be below the asymptote on the right side and above the horizontal asymptote on the left side. Now, again, you're going to be using your calculator for determining these values. Okay? So I know it can be annoying for something like this one where you say, okay, I got to do negative 1,000 so negative 1,000 times negative 1,000 minus 1. Okay, and then your denominator, negative 1,000 plus 2 times negative 1,000. And you might be saying, why don't you just use the fraction button? Well, I want you to be able to do this without a graphing calculator. So now then we can see that the numerator part divided by this 1.001. All right, so now we can graph this. We know that the left side is above the asymptote and the vertical behavior is positive. Then this vertical behavior is negative, so it comes from the bottom, touches the 2 points here, and the vertical behavior of the second asymptote at x equals 2, the left side is down. So we go down here. Then the right end behavior is positive, but our graph doesn't go like this because we are above the asymptote there. And we know that on the right side, we need to be below the asymptote. So what actually happens is we cross the asymptote and then we come back up like this and get close to it. All right, so that is our introduction to graphing these complicated rational functions. And I know it's a lot of work, a lot of steps that you have to do. That's why we only did a couple of them, and you only have a couple in your assignment. But make sure you do each step of this process and really ask yourselves, what does this mean, and take your time on this. So thanks for watching. Make sure to like the video and subscribe.